Imagine you're practicing for a 100-meter race on a track, and suddenly someone asks you to stop immediately within a second. Will you be able to do that? What if someone asks you to turn to the right? Will you be able to turn immediately? The answer for the both questions would be a no. You can stop, but gradually. You can turn, but not shortly. And guess what? That's the same story with every object.
Every object will continue to do what it's doing. If it's at rest, it will remain at rest. And if it's in motion, it will stay in motion. But what can change this? Yes, only an unbalanced force can change this. And this is nothing but the Newton's first law of motion. An object at rest stays at rest, and an object in motion stays in motion with the same speed and same direction unless acted upon by an unbalanced force. Do you remember the Newton's first law of motion? It says that an object will continue to do what it's doing unless acted upon by an unbalanced force or some net force. And the important question is, what happens when there is net force acting on an object? That's precisely what the second law of motion will discuss.
If the forces are unbalanced, then there will be acceleration. On which two factors you think the acceleration depend on? Okay, let's say you put a toy car on a table and you apply a net force of 10 units on it. And then you apply a net force of 20 units on it. In which case you think the acceleration will be more? Yeah, of course, the one which the force is more.
Let's say there are two objects on the table, one with the mass of 3 kg and the other one with mass of 5 kg. Now, if you apply net force of 10 units to each of them, which one do you think will accelerate the more? Surely it's the 3 kg one, because it has lesser mass. Lesser the mass, more the acceleration, and more the mass, lesser the acceleration. If the force is more, then more will be the acceleration, and if it's less, then less will be the acceleration. Acceleration depends directly on the net force, so it's clear that mass is the second quantity the acceleration will depend on. If you understand this concept, well, then understanding the second law of motion will be very easy. So, from here, it is clear that the acceleration is directly proportional to the net force applied and inversely proportional to the mass of the object. The only question you have to ask yourself while studying the third law is, what happens when two objects interact with each other? What happens when you place a ball on the table? The ball will exert a force on the table and the subject exert an upward force on the object. There are two forces that result from the interaction, the force on the table and the force on the object. The magnitude of the two forces are the same, but the directions are opposite. These forces are called action and reaction forces. What we saw here is nothing but Newton's third law of motion. Every action has an equal and opposite reaction. Imagine you're sailing in a boat and there is a hole in your boat. Now, how are we gonna reach the shore? Don't worry, do as what I say. Jump in the water and push the water backwards with your hands. No, just jump. No, you are not pushing the water backwards. See, you are moving forward to the shore. Do you know why we are able to move forward while pushing the water backward? To understand this, you have to learn about Newton's third law of motion. Newton's third law of motion states that for every action, there is an equal and opposite reaction. When we swim, we apply the force and push the water backward with the help of our hands. This is action. In response to this action, the water pushes us forward with an equal force. This is reaction. When the rocket burns its fuel, it exerts a force on the ground. In return, the ground exerts the same amount of the force over the rocket. When thrust provided by the burning fuel exceeds the net downward force caused by the rocket's own weight and gravitational pull of the Earth, the rocket starts lifting off and makes its way to space.